Hello, I am Dina Portman. I am a developer relations engineer with Google Cloud, and I am the lead on the 4Keys project. And my talk today is Measuring DevOps, how to make the 4Keys project work for your organization. Okay, let's start with some definitions so we're all on the same page. First of all, what is DevOps? Well, there are a lot of definitions for DevOps, but this is the one that we're going to use. DevOps is an organizational and cultural movement that aims to increase software delivery velocity, improve service reliability, and build shared ownership among software stakeholders. In other words, DevOps is a way of using communication and automation to increase velocity and reliability to make happy users. Now, another word that you're going to hear me throw around is DORA. DORA is the DevOps Research and Assessment team. And through 6 years of research, they identified 4 key metrics that are predictive of success, which is a very strong relationship, stronger than correlation. And roughly, these 4 key metrics fit into 2 buckets: speed and stability. On the speed side, we have deployment frequency and lead time for change. And on the stability side, we have change fail rate and time to restore services. So now I'm going to quickly go through the 4 key metrics and their definitions. The first one is deployment frequency, which is how frequently a team successfully releases into production. And for example, this could be weekly, daily, monthly, yearly, etc. And then the other speed metric is lead time for change. And this is the median amount of time for a commit to be deployed into production. Now, on the stability side, we have change fail rate, which is the number of failures per the number of deployments. So for example, if you had 4 deployments in a day and one of them caused a failure, then that would be a 25% change failure rate for that day. Next, we have time to restore services. So for a given failure, or for all your failures, this is the median amount of time between the deployment, which caused the failure, and the restoration. Okay, so I would really love to talk a little bit more about the DORA research and all the capabilities and all the outcomes, but we don't have time for that today. So we're going to stick to the 4 key metrics, and we'll talk a little bit about implementation. So when DORA did their research, they used surveys, and that was great. They had 6 years. They had a lot of participants. They used very rigorous statistical academic methods. But when I'm thinking about just my organization, I don't necessarily want to use surveys, because then we're just one little data point, and we're very open to bias. And so if we can, we'd like to use systems data. So the good news is you have all of the data that you need to calculate the 4 key metrics. The bad news is it's in like a dozen different systems. So what do? Well, we created the 4 Keys project to help automate the collection of this data and the calculation of the metrics. The real challenge with creating an open source project that will be able to accept data from these dozens of different systems that we might not even be aware of yet, that you might be using a tool that I've never even heard of. And so how do we build something that can integrate with all of these things we don't even know about? Well, the solution that we came up with was to create a very generalized pipeline that takes in events via webhooks and then ingests them into BigQuery. So to start with, we have the events happening at their source. And every time an event happens, we send that event to our webhook, which is the event handler. And per source, we have a pub subtopic and a little data parser that does some very, very light data mapping, very light ETL here, and then puts that into a BigQuery table that is just append only. So we're just adding rows. And then from there, we have some derived tables, and then that feeds into our dashboard. So these are the tables of the 4Keys project. We have the raw events table. This is, in essence, a DevOps log. It should contain every event related to development, deployment, and incident management. When in doubt, stream it into this table. Even if you don't necessarily think that you're going to need it, it's better to have the data because things change and then you might need that data. So from the raw events table, we create these 3 derived dimensional tables: changes, deployments, and incidents. So I'm going to go over the dashboard pretty quickly. Down the center, we have the metrics as defined by the DORA research, and they are separated into the different buckets that the DORA research separates them into. So if you have good or elite performance, then this will be represented with a green badge. If you have medium performance, you'll have a yellow badge. And if you have poor performance, it would be a red badge. And then around the edges there, we have these little daily charts that are just showing the system's data day to day. And these are really nice because they can act as early feedback. So if perhaps you have adopted a new change management system, this could be an early sign that things are going in the right direction. Or it could be an early warning system that things might not be going in the right direction. So that's the dashboard. So let's start talking about how do you make it work for you? Because as I said, we don't know your business. We don't know what tools you're using. We've built in some reasonable defaults and a couple common data sources, and we've done the data mapping for that. But obviously, we're not going to account for every single use case right out of the bag. So, how do you make it work for you? So let's start by talking about adding new data sources, new integrations with the 4Keys project. So in order to do that, we are going to have to edit the event handler. We're going to have to create a new pub subtopic, and we're going to create a new data parser. And I have a little video that I am going to play here and talk you through, showing how you can add a new source. Okay, so this is sources.py, and these are event sources. Each event source has a name, a signature header, and a verification function. Because we don't just want to accept any old thing from the open internet, we want to make sure it's authorized. And some sources have very complicated ways of authenticating their messages. Others just have a very simple verification system. So I am going to build in a new source, and we'll say this is this very cool new Git system. It's not GitHub, it's not GitLab, it's totally new. It's a cool Git hookshot. And it is an event source. In our table, we want it to be called coolGit. And in the headers of the event coming to our webhook, the token is going to be in the header coolGit secret. And it's just using a very simple token verification, just comparing, is the token in this field the same thing as what we're expecting? Okay. So now I am going to redeploy the event handler with this new source authorization logic in it. And I'm going to just send it a quick message with curl to make sure that that worked properly. Of course, if I were using a real system, I'd use the little test button to make sure that that integration was working. Okay, so that works. Excellent. Onward. Okay, so now I need to create all that pub sub stuff. And we created this little script to try to make that a little bit easier. And so we're putting in the user agent of the source is cool get hookshot. And then you saw I put in cool get. That's going to be the name of my worker here. Okay. So it did all the logic. It did all the piping. It did the permissions. It created the pub sub. So now, one of the things that it did was it also created this new directory in my source right here. And this is just copied from a template. This is what, the workers basically look like. They're looking for pub sub messages. And we're going to process the new source event. So this is where the data mapping happens. So what I would do at this point is I would look at the payload from the source, and I would look at what they're calling these different fields, how they're nested, and then I would map that to these fields that my BigQuery table is expecting. So it's expecting all of these fields: event type, ID, metadata, time created, signature, message ID, and source. And the metadata is just the entire body of the event. So here I am, doing this data mapping, making sure that I'm pulling out the correct fields from the message that I am piping through my little ETL system here. And the source, we want it to be called cool get when it shows up in the table, because it is the coolest get. I'm double checking. Okay, everything looks good. So let's redeploy this. Oh, look at all my nice files there. Okay, here we go. Putting in the substitutions. This is just my command to deploy this. And there it goes. So this is going to build the container. It's going to push it up. And everything else is already set up. So, the event handler knows to accept from this new source and knows how to verify that it's an authorized source. The pub subtopics are set up. They have the correct permissions to push to our worker. And now I'm going to test posting to it. And if I did it correctly, we are going to see some data in our table. It will have gone through that entire pipeline, that whole system. And so there'll be some data here. Okay, so we're just gonna select star from events raw, where the source equals cool get. That is the source nickname that we put in the table. And voila, there it is. That is the data that I just posted to the event handler. Excellent. Okay, so once you've created a new source, well, you submit a PR. Please and thank you. We have a roadmap that lists all of the integrations that we want to build. Very common integrations, lots of tools that people commonly use. And so if you do go through this process and you happen to build a new integration with Spinnaker or Jenkins or something on the roadmap, then please do submit a PR. It would be very, very highly appreciated. Not only would you be making Forkeys work for you, you'd be making Forkeys work for a lot of other people. Thank you. Okay, so next we come to data definitions. The derived tables are all done via SQL. And the nice thing about that is you don't have to redeploy anything. You just have to dig into the data, understand your sources, and then adjust the queries so that the output matches how you conceive of your operations. You just have to understand the data. Easier said than done. Okay, so let's start with deployments. These are some examples. Obviously, this will not be an exhaustive list. And by the time I'm done going through them, you're going to be saying, oh yeah, we get it. You add something to the SQL. But people have asked me for concrete examples, so I'm giving you examples. So deployments, we're going to start with the traffic percentage. Because if you're doing some kind of canary rollout, maybe a successful deployment to your organization is any traffic at all has reached the user. or maybe it's 5%, or maybe it's 50%, maybe it's 100%. And that will be distinct and unique to your organization. And so in this example, I am controlling my rollouts with Cloud Build, and I'm using a variable for traffic. And so every time this runs, this is going to post an event to the event handler. And in the body to the pub sub message, it will have the variable for traffic. And I'm going to use that to query. I'm going to dig in to that metadata, which is the entire body of the message. And I'm going to extract the field that I care about and filter based on that. So in this example, I am only looking at deployments where the traffic is greater than 75%. And so you do that by editing that deployments.sql table that is in the source of 4keys. Okay, so next we have environment. So it's very common to use different projects for your prod and your staging environment. And obviously, if we're only talking about successful deployments to production, then we only want to include the deployments to production. And so in this example, I'm pulling out the project ID and ensuring that it is my prod project. Next thing we have are changes. So maybe you have a different type of change than we've included in the default scripts. GitLab and GitHub use different words for pull request and merge request, and maybe you have a new type. So you would add that into the changes.sql script, and then you would have a new type of change. Incidents. In the example that we give in the project, we are looking at GitHub issues that have an incident label. And maybe you want to use a different system, or you want to use a different label. In that case, you would go in and you would edit this incidents.sql SQL. Another thing I've heard, obviously this is super common, especially if you have like a microservice architecture, is using multiple repos. And when we're looking at commits, those are unique SHAs. And so we don't worry about joining them and it getting confusing. But with things like issue IDs, there will be a little bit of confusion there. And so to create a unique ID, then you would concatenate your repository ID with your ID like so. So then, once you've edited the SQL, you would schedule the query. And so here's a little video of that. It's very simple. You just run the schedule script. I am doing deployments.sql. The table is deployments, and that is my project ID. And then a couple seconds later, BigQuery will respond, yes, the query is scheduled. Okay, so we've gone over how to add new sources and then also how to adjust your data definitions. So now what? So at this point, you should have a dashboard and it's bringing in all the data that you want, and you've really encapsulated your deployments and changes the way that you want to. And maybe you see that your lead time to change isn't very stellar and you want more insights. So it's important to note that the dashboard template, it's a starting point. The metrics are a starting point. And so if you see that your lead time to change is poor, then you may want to write some more queries to really dig in to what is happening perhaps before or after the peer review. How much time from when the code is integrated to deployed? Where precisely is the bottleneck? So you can write more queries, you can add more pages to the dashboard, you can even use your own dashboard. The data is there, and we provide queries for you and a template for you, but you are absolutely welcome to use whatever you like and build your own charts. So please do join us. Please do get started. Please do get involved. You can install the project. We have a bit.ly link here. It's, the 4 Keys project. You run a setup script. It does a whole lot of things for you. If you want to read a little bit more, we have a blog post up on the Google Cloud blog. And you are also welcome to join us on Slack. And that's it. I would be happy to answer any questions that you have. Hello. Can y'all hear me? Okay. Awesome. Great. Wow. Thank you for watching my talk. I'm gonna jump in and start answering some of these questions that I didn't get to in the chat. So the question here is, are there other customer measurements for successful deployments, like performance or number of bugs? The answer to that is yes, absolutely. There are so many metrics, and especially depending on your domain, that you can use. The nice thing about the 4 key metrics is that they are not industry specific. They are applicable to every kind of organization that does software delivery, and they are backed by research. And so I've worked on a lot of different teams, and I worked on analyst teams where we've done our absolute best to come up with metrics that more or less reflect the questions that we're trying to answer, but it's always a little bit proxy, and they're always a little bit guessing that these are possibly reflective of something that is happening in reality. And the nice thing about the 4 key metrics is that we know that it's not just a correlation. It's not just, some kind of proxy. Like, these are actually predictive measurements. So for me, I would always want to look at the performance of my organization using the 4 keys, but then having other metrics that I can drill down into organizationally, because these are metrics that don't necessarily guide your day-to-day operations. They're very high level. When we look at it, when we think about it, we think about what our performance is like over the past quarter, not the past day, because and that is, because people have different patterns of rolling out software. And yeah, essentially they're designed to be high level, but there's a lot going on underneath the hood. So I would encourage you to use those metrics, use the 4 keys to isolate where you need to pay attention. If your lead time is really, really high, then I would start looking at metrics in that area to try to understand where's the bottleneck, and then drilling down that way. Okay, there's one question. Avery, you have a question in the Q&A. If projects have large gaps in time between major development, how is that reflected in the metrics? And can we subtract non-working hours from total time? So if there are large gaps between development, it's going to look like a poor performance. There's kind of no way around that. And I would not subtract non-working hours from total time, because at that point you're starting to get into these kind of you're optimizing for these edges. And we're getting away from the point. And one of the points is we want to know ultimately how our customers are experiencing the software that we're delivering. And if you start a PR at 3 p.m., you stop working at 5, the next morning you finish it at 10 a.m., well, your total working time might be, 3 hours. But that overnight time, that's time that people all over the world have not gotten your new feature. And so again, these are high level metrics. They're supposed to be zoomed out. If you want under the hood to like understand a little bit better about, your batch size and how much time your developers are actually spending on it, then that again would be a drill down metric. So high level, you want to keep it just as high level as you can. And then anything that you want to drill down into to better fine tune your operations, you can do that. But ultimately, you do want to keep going back to the 4 key metrics to ensure that you're steering your ship in the right direction. Okay. Do you consider escaped defects, i.e. bugs that are found in production, to affect change failure rate? If so, what do you do about a bug that's found but not fixed until 2 sprints later? It's a great question. Yes, those should be considered. And that is why I am very passionate about having some sort of like in your incident manager or whatever system you're using, some sort of way to tag the exact deployment that caused a bug. Because like you said, you might not find it until a week later. And then once you find it, maybe you fix it really fast. But that doesn't change the fact that your customers have been suffering from this bug that escaped you for a week. And so ultimately, the great thing about that is it's data. It'll be very poor. It'll be like relatively poor performance for that time period. But once you have that data, you can see how exactly that it went through your system. And then you can start putting in different guardrails and different checks to try to prevent that from happening again, try to detect it earlier. So yeah, we don't want to, these aren't, if you have a poor performance, it's not a penalty. Like it's not meant to punish anyone, any particular person, any particular team. It's not like saying, hey, you did a bad job. It's really just a matter of saying, these are the areas where we can improve, and hiding that does not serve you and it doesn't serve the customers. So we want to be able to see exactly how long our lead time actually is, and also like how long it takes for us to find and then fix the bugs. Okay. Oh, Brian Colfer had a question or some comments about being able to use just open source tools. And I think that is a great idea. We've had a lot of people ask about whether or not we could create a version of this that runs in pure Kubernetes. And I would be absolutely delighted if somebody submitted a PR that did that. I think that would be great. And on the one other note on the like pure open source section is we are working on migrating our dashboard template into Grafana, which is open source dashboard instead of Data Studio. And again, that also like runs in containers. So, I mean, right now, that you could absolutely do all of this using open source tools. It's a very container heavy architecture, and the setup script just to do like a really easy bootstrap. It just pushes everything into like Cloud Run and PubSub and things like that. But there's no reason, there's nothing special and unique about this, about all these different tools. There's no reason why you couldn't use another one. The only exception to that, I think, is BigQuery. Is the as a previous data analyst, data enthusiast, data scientist, and now a data engineer, I have a lot of love for BigQuery, and I don't know that anything else really does this stuff as well as BigQuery does. But I mean, we're writing SQL. Honestly, you could probably use any kind of SQL database, any relational database, and it'll work, and it would be great. Okay. other questions do we have? Marcy had asked how poor is poor performance? For instance, median time of commit to get to production. So I would encourage you all to go to the Google Cloud DevOps page and look at the DORA research. And so like poor performance is, I think it's like, you know, like a month or something for lead time to commit. I mean, for lead time to change. And yeah, it's all about finding your starting place and then working from there. Oh, okay, it looks like we are out of time. Yeah, target should always be improving. Quick note on that. Absolutely, that, you know, find where you are, keep trying to improve it. And that's also why in the template, in the dashboard template, we move away a little bit from the, you know, the DORA buckets. We show them, but there's also those kind of running logs of how your performance is trending. And I did want to keep the original data definitions in the buckets because that's the research, and everything that we do in the 4 Keys project really should be rooted in the research. But yeah, the running logs are very helpful because they can show you, yeah, my lead time is going up or down. I've got this new experiment going, and this is how it's affecting my metrics. Okay, great. Thank you. That is all the time we have.